In this video, we'll take a look at solving a couple of problems using right triangles. And in the first example, we're told that the angle of elevation from Evelyn's window, so here's Evelyn's window, so this is Evelyn's building, on the left to Betty's on the right. So Betty's window's up here, a little bit higher on this building across the street. So the angle of elevation up here is 15 degrees. Angle of elevation means the angle a line of sight makes with a horizontal. It's called elevation if you're looking up. The angle of depression from the top of Evelyn's building, so this would be the top of Evelyn's building, to Betty's window, which would be this line of sight, that's 20 degrees. Angle of depression is an angle a line of sight makes with a horizontal, so angle of depression because we're going down. And in A, we're asked to find the width of the street between the buildings. So we're asked to find this horizontal distance across here or across here. We're going to work with this right triangle, and we're told, it's not listed in the question up here, we're told that Evelyn's window is 20 meters above the ground and Betty's window is 25 meters above the ground. And so that would tell us in this little skinny right triangle that, see, Betty's window is 5 meters higher than Evelyn's, so in the diagram this side would be 5. So we're asked to find this side. I'm going to call it B for the distance between the buildings, B for building, and that's the adjacent side for the 15-degree angle. This side right here, this 5-meter difference in height between the two windows, is the opposite side for the 15-degree angle. And so we're working with opposite and adjacent. So if you remember SOHCAHTOA, opposite and adjacent is tan. So we would use the tan ratio to find this distance across here. And so for A, I would write tan is opposite over adjacent. So filling in what we know, the angle is 15 degrees. The opposite side is the 5. And B, the distance between the buildings, is the adjacent side. Now, I'm trying to solve for B here to rearrange. So this is what it would look like. We would multiply both sides by B to get the B out of the denominator. And so the idea for that is so that those b's divide out. And then we would divide both sides by the tan of 15 degrees. And so that would look something like this. And of course, the reason I'm dividing by the tan of 15 on the left here, and I do the same thing on the right, is so that those tan 15s on the left would divide out. And so after they do, we get b on the left here is equal to 5 over tan of 15. So b is 5 over the tan of 15. And so if I bring my calculator in, 5 divided by the tan of 15 degrees is 18.66. So I'm going to round to 1 decimal place, and I'll write 18.7 meters. So 18.7 meters is the distance horizontally between the two buildings, so that's what we're asked to find in A. For B, it says how tall are the buildings. Now, what we could do to find the height of the buildings is, see, Evelyn's window is 20 meters off the ground, so we could find the distance from Evelyn's window to the top and add that to 20. But it would probably actually even a little bit easier if we worked with this side. See, we know that Betty's window is 25 above, so if we work with this right triangle here and find this distance, we could add that to 25, and that would be the height of her building, and they're both supposed to be the same. So in this triangle up here, 18.7 is the adjacent side we just found. So in that right triangle, we know that length is 18.7. That's the adjacent to the 20-degree angle. And so we're looking for the opposite side here. I'm going to call it height, H for height, not H for hypotenuse. And the trig ratio, again, that involves adjacent and opposite is tan, so we're going to use tan again here. Not every question involves tan, but these do, both do. And so we fill in the values that we know. The angle is 20 degrees. The opposite side is what we're finding. We'll call that H, and the adjacent side is the 18.7 we found in A. And so in order to rearrange and solve for H here, I would just multiply both sides by 18.7, and that's how I could isolate the H. So 18.7 on this side, same over here. The purpose of that is so that these divide out, and I now have H isolated on the right. It's equal to 18.7 times the tan of 20 degrees. And so that calculation would look like this. So we would multiply 18.7 by the tan of 20 degrees, and we get about 6.8. So that's the h distance. So to find the total height of the building here, we would add that 6.8 there to the 25, and that works out to 31.8 meters. So that's how tall the buildings are. Second example, we have an 80-meter tall communication tower. So here's the communication tower. This side here would be 80 meters, and it needs a guy wire. It's a support wire. They're often called guy wires. That's just the name of them. Attached to support the tower. And it's supposed to be attached at an angle of 70 degrees with the ground. So we would put a 70-degree angle in here. And we're asked to find how long the wire should be cut if we need 2 meters of fastening for the top and, of course, for the bottom as well on either end. Now, in this right triangle, this side right here, that's the height of the tower, so that's the 80 meters. And we're asked, and that's the opposite angle, side to the 70-degree angle. And we're asked to find this side right here, which I'm going to call G for guy wire. And that would be the hypotenuse because it's across from the right angle. The trig ratio that involves opposite and hypotenuse is the sine ratio. So that's why we would use sine here. So we'll fill in the 70 degrees and the opposite in the G. So the angle is 70, the opposite side is 80, and the hypotenuse is the G variable. And so we're asked to solve for G here. And so what we would do mathematically to rearrange and solve for G, we could multiply both sides by G. And the purpose of that is so that these G's divide out. So we now have G sine theta equals 80. I want to isolate for G. So I would divide both sides by the sine of 70 degrees. So basically over here we have 80 divided by the sine of 70. These divide out. And so that's what G equals. G, the calculation, it's 80 divided by the sine of 70. That's the calculation. So let me erase my writings here. And so we would divide 80 by the sine of 70. And so that gives us 85.1. So G is 85.1 meters, and of course we need the 2 meters fastening, or 2 meters of wire on each end, so we need to add 4 meters to this to get the total length. So we would need 89.1 meters of wire to make that guy wire, that support wire. And that's the end of the video.